Hello friends, in today's lecture I'm going to show you how to solve some more problems by the method of integration by parts. These problems are a little bit more complex than what we have done in the previous lecture. So I hope by the end of this lecture integration by parts will be clear on how to solve such problems. Okay, so let's take the first example. Integration of e to the power x sine x of dx. So we take the first part again, we take this as the first part and this as the second part. So the first part is u is equal to e to the power x. Therefore, we have du by dx is equal to e to the power x, as we know from differentiation. So dx will be going to the other side. So du is equal to e to the power x dx. Okay, and dv is equal to sine of x dx. So now if we integrate both the sides, we get v is equal to minus cosine of x. So now we apply the formula for integration by parts, that is integration of u dv is equal to uv minus integration of v du. Okay, so integration of u dv we know is integration of e to the power x dx. Okay, sorry, integration of e to the power x sine x dx. Now what is u? U is e to the power x. What is v? V is minus cos of cosine of x. So we can write minus here, and this is minus cosine of x minus integration of v. What is v? Minus again cosine of x, and du. What is du? Du is e to the power x dx. Okay, so this is what we get. So this is equal to this minus we can have here as a plus here. Okay, so now again we find that there is an expression similar to this expression, integration of cosine of x e to the power x dx. So again we will take up this expression now. So let's take u is equal to again e to the power x and du. So for du is equal to e to the power x dx, and dv is equal to cosine of x dx. Integrating both the sides, we get v is equal to sine of x. Okay, v is equal to sine of x. Again we apply the same formula that we have applied here. So integration of u dv is equal to uv minus integration of v du. Therefore, what is u dv? U dv is again e to the power x cosine of x dx. That is expression. That is the expression here. So what is u in this case? It is e to the power x. What is v? Sine of x and minus integration of v. What is v? Sine of x. So it is sine of x e to the power x dx. Okay, now we substitute, since this is the expression for this expression is this one, we substitute this expression in place of this one. So what do we get? We get like this, integration of e to the power x sine of x dx. This is the expression here. Integration of e to the power sine x dx is equal to minus e to the power x cosine of x. Okay, and we have plus integration of this one. So we will put this in the brackets. So we have e to the power x sine of x minus integration of e to the power x sine of x dx. Okay, this is what we get here. So if we remove the brackets, we get minus e to the power x cosine of x plus e to the power x sine of x. Plus and minus becomes minus integration of e to the power x sine of x, sorry, forgot the x here, sine of x dx. Okay, and we have the constant of integration, and we have the final constant of integration. of two integrations. We have a constant of integration here and we have a constant of integration here. We can group this together as one constant of integration here. So this becomes, now we see that we have e to the power x sin x dx here and e to the power x sin x dx here. So we can take this to this side. So it becomes 2 integration of 2 e to the power x sin of x dx is equal to, we can say, e to the power x sin x minus e to the power x cosine of x. Okay, and see, finally this 2, if we divide both the expressions by 2, we will get integration of e to the power x sine of x dx is equal to half e to the power x sine of x minus e to the power x cosine of x, and the constant of integration plus c. Okay, so this is how you solve a problem involving is an exponential expression and a sine expression. And okay, let's take another example. Now, in this example, you will see that we have an expression, an algebraic expression x to the power 5, and another expression e to the power x to the power 3. Okay, in this example, you will see that we are applying integration by substitution and integration by parts. Let's see how you do it. So we will say, first of all, let z be equal to x cubed. The reason we have put z because will be finding u and v. We'll be having expressions of u and v in the integration by parts part of the problem. Okay, so let us substitute first. So we are applying substitution first. Z is equal to x cubed. So we are substituting this one with z. Okay, so as we know, dz by dx is equal to 3x squared. Okay, so let's substitute in this expression. So this will become integration of x to the power 5 e to the power x cubed dx is equal to, now x to the power 5, okay, e to the power z, e to the power z, okay, because we have substituted z equal to x cubed, and what is dx equal to, dx will be equal to dz by 3x squared. Okay, okay, so this x squared and this one will cancel. We will be left with cubed here. Okay, cubed here. So x cubed, as we know, we have substituted for z. So we can write this expression, instead of x cubed, we can write z e to the power z dz, and this 3 we can take it outside the integration sign. So now you have this expression which we will have to integrate using integration by parts. Let's see how to do it. Okay, so this one will be integrated by parts. Now we'll apply integration by parts. Let's see. So let's us put u is equal to z and dv equal to e to the power z. Okay, now if you differentiate this expression, du by dz is 1, so du will be equal to dz, and if you integrate this expression, we get v is equal to e to the power z. Okay, now we apply the formula for integration. Integration of u dv is equal to uv minus integration of v du. Okay, so let's see this one. So integration of, we have z e to the power z dz is equal to u. uv is, u is z and v is e to the power z. Okay, so we already have that. And what is v? V is e to the power z, and we know du is integration, du is dz. So and we apply the integration of the constant of integration c. So we have now And we know that integration of e to the power z is e to the power c, that is c. So now we have nothing left but to substitute back the values of z back again. So, but since this was 1/3 of this one, this expression was, so integration of x to the power 5 e to the power x cubed dx is equal to 1/3 of integration of z to the power ez by dz, which is equal to 1/3. 1/3, this is z e to the power z is that one, so it is z e to the power z minus 1/3 e to the power z plus c. So now we just have to resubstitute z equal to x cubed to get the final expression. So we get here 1/3 z is equal to x cubed, so it is x cubed e to the power x cubed minus 1/3 e to the power x cubed plus c. So you see how we can solve such problems by integration of paths. This is all for today's lecture. Thank you.